So let us now move on to problem number 2. A flange bolt coupling is consist of 6 10 mm diameter steel bolts on a circle that is 300 mm in diameter, and 4 10 mm diameter steel bolts on a concentric bolt circle that has 200 mm in diameter. What torque can be applied without exceeding a shearing stress of 60 megapascals in the bolts? So first, what do we mean by concentric circles? These are circles with a common center but of different radii, just like what was drawn in the figure on the right side. We can see the concentric circles having two different radius, R1 and R2, R1 being the outer circle bolt and R2 being the inner circle bolt. Therefore, the force P1 experienced on the outer circle for each bolt is different from the force P2 that's present on the inner circle bolts. This is primarily due to the distance of the bolts from the center, because the greater the distance, the greater the force. So let us now move on in identifying the given of the problem. For the inner circle, we have N1 equals to 4 is the number of bolts, D1 equals 10 millimeters, it's the diameter for each bolt, and R1 equals 100 millimeters, which is equal to the radius of the inner circle. For the outer circle, N2 is equal to 6, the diameter is also equal to 10 millimeters, and the outer radius is equal to 150 millimeters, which is evidently greater than the inner circle radius. For our required variable, we are looking for torque. In order to solve torque, we must find first the value of the forces acting for each bolt in the inner and outer circles. P1, forces in outer circles, can be found first because they are the one experiencing the maximum allowable shearing stress, which is equal to 60 megapascals. Substituting all the given values into the equation, shear stress equals force over area, whereas A is equal to the area of the bolts and is given by pi over 4 times diameter squared, would give us the value for P1. And P1 is equal to 4712.39 Newton. Now that we know the value of P1, we can finally get the value of P2, using the ratios of the force to the radius, which comes from the equation P all over AGR, where A equals to the area of the bolt, G is equal to the modulus of rigidity of the bolt, and R is equal to the radius of both circles. In this case, the diameters of all the bolts are all equal, thus the area will be cancelled. Also, the modulus of rigidity is the same for all the bolts because they are of the same material, even if it's not stated in the problem, hence cancelling both G from the equation, leaving P over R. After simplifying the equation into P over R, we can now finally substitute all the known values into the equation and find P2, whereas P2 is equal to 3141.6 newtons. After all the necessary variables has been set, we can now finally solve for torque, which has a formula of PRN, and in this case, it will be P1 R1 N1 plus P2 R2 N2 because there are two bolt circles. Inserting all values in all variables in this equation, torque can now be finally solved. Therefore, torque is equal to 5,497.8 Newton meters.
Created using Powtoon.